Today our topic is to learn about modulus functions. This is chapter 2 from Pure Mathematics 3 and part of the modulus function will appear in further mathematics 2 chapter 1. Before we come up with the modulus functions, we have to understand the notation of this modulus sign. That means if we get modulus of 3, this is the notation for modulus of 3. We have already learned in our AS level grades. And if we happen to find the modulus of 3, we know that answer is 3. Then if you want to find the modulus of minus 3, that answer also 3. Then what do you mean by this modulus? This modulus implies the magnitude of the function inside it. That means we get the magnitude of this, but the magnitude of 3. That is, magnitude of 3 is 3. And magnitude of minus 3 also 3. That is what you mean by the modulus function. Then how do we get a modulus function? The theory to find the modulus function is if the function inside the modulus mark is a positive value. If it is a positive function, we can keep the same thing as it is. So if I get the modulus of 3, I just wrote the same thing itself. Then if this term inside the modulus is a negative value, if it is a negative value, according to the definition, we can put another minus in front of this and we can write it. For example, if you want to get the modulus of minus 3, we can put to get the to get 3, we can put another minus in front of that. That means you get minus 3 turn up to plus 3. If I repeat it back, if you get a term or expression inside the modulus is a positive value, you can write the same thing itself. If the term inside the modulus is a negative value, you can put added minus and you can write it. There you get the modulus of the term inside the modulus mark. Right, there. This is the definition. If the function inside the modulus is a greater than 0 value or a positive value, we can write the same thing itself. If the function inside the modulus is a negative value, we can write the same function with a minus in front of that. That is the definition of the modulus function. In this topic, we are going to discuss about modulus graph. There are two types of modulus graph we are learning. The first type is the modulus of the whole function. Modulus of the whole function. And the second type of the graph is we just try to find out the modulus comes with only the variable in the function. In future slides, we will understand that how to draw these two graphs separately. Right. Initially, we'll try to understand how to draw the modulus of Fx. That means the modulus come to the entire function graph, right? For example, if you want to find modulus of x plus 2 graph, how do you suppose to draw? The step 1 is you have to draw the graph of y equals to Fx. That means without modulus, you have to draw the graph. That means if you want to draw the modulus of x plus 2, we have to draw just x plus 2 graph. Just x plus 2 graph. Then what you need to do? The second step is reflect the negative y coordinates by x-axis. That means you can see this is the y equals to x plus 2 graph. So it's traveling through plus 2 and here traveling through minus 2, intersection with the x-axis and y-axis and x-axis. Then you can understand that this part of the graph is negative. Then up to here doesn't make a difference. So you can draw same thing up to minus 2. Then after that, this negative part, what happened? Reflect from y-axis. Reflect from x-axis. This negative part of the graph reflects from x-axis. That's a theory to draw the modulus of whole Fx graph. Right. So that is the answer for this question. Let's go ahead with another example. Over here, if you want to draw modulus of 2x minus 6 graph, initially we have to draw y equals to 2x minus 6 graph. So if you draw this, you can understand this traveling through 3 here and minus 6 here. Then this is the negative part of the graph below the x-axis graph. This below x-axis or the negative part reflect from x-axis. Therefore, this part reflects. So over here, this part reflects somewhere like this. Then you can say this is passing through minus 6. Therefore, the reflection travels to plus 6 itself. This is the graph of modulus of 2x minus 6. In this example, we have to draw y equals to x squared minus 6x minus 16 whole the modulus graph. Initially, we have to draw x squared plus 6x minus 16 graph. You can say, if you draw this, if you factorize it, you get the factors of x minus 8 and x plus 2. Therefore, you will obtain the answers. The intersection of the x-axis become plus 8 and minus 2. Then intersection of the y-axis become, if you make all the x coordinates 0, it's minus 16. Then the minimum point, you can use differentiation or the completing squares method. There you get the minimum point 3 comma minus 25, right? Okay. Then what you need to do is you have to draw the modulus graph. What happened to the modulus? This negative part reflects to the positive side. This is a graph of that. Therefore, this minus 16 turn up to plus 16. 3 minus 25 turn up to 3 plus 25. This minus 2 and plus 8 remain as it is. Then this negative part of the graph is the negative part of the graph. This part reflects to the positive side. That is the theory of drawing entire modulus graph. So this is the graph of that. Right. If you want to draw y equals to modulus of 1 over x graph, initially to draw 1 over x graph. Hopefully, we know how to draw 1 over x graph from our AS knowledge. Then if you want to get the modulus of 1 over x graph, what happened? This negative part of the graph reflects the positive side. So this reflects on x-axis. So it would be somewhere like this. So this is the graph of modulus of 1 over x graph, right? If you want to draw modulus of 1 over x plus 3 graph, initially to draw 1 over x plus 3 graph. Here we have already learned how to draw 1 over x graph. That means 1 over x plus 3 means what happened? This entire graph shift from 3 units up. So here you can understand that here the axis of asymptote is y equals to 0. It shifts from 3 units up. So it will turn up to y equals to 3. All other facts are the same, right? Then what happened here? The modulus part of it. This one or this axis of asymptote up to here doesn't make a difference. Only thing is that this is the only part where you can see it's negative. Then what happened? This negative part reflects to the positive side. So this part from here bottom, this part of it reflects to the positive side. That is the graph of modulus of 1 over x plus 3 graph. Let's move up to draw modulus of 1 over x plus 3 graph. Right. So in this case, initially you have to draw 1 over x plus 3 graph. That means you can say over here, this graph, it's 1 over x plus 3 means the graph, entire graph shift from 3 units to the negative side. Here the axis of asymptote is x equals to 0, it turn up into x equals to 3. Then after that, you can draw the as it is. Then what you need to do is you have to draw the modulus graph. Then what happened? This negative part of the graph reflects to the positive side. Here, this part reflects to this side. Like that. So yeah, therefore you can obtain the graph shape somewhere like this. That is the answer for that. Then the next graph is modulus of sine x graph. Initially to draw y equals to sine x graph. You know that how to draw y equals to sine x graph. It travels to 0. It's pi by 2 here. Pi it's plus 1. Pi 3 pi by 2, that is minus 1. 2 pi, like that goes on, right? If you want to draw the modulus graph, what happened? This all the negative parts reflects the positive side. So this part reflects, it's over here. This part reflects, it's over here. Like that, all the negative portions, these negative portions reflects the positive side. That's what you need to get it from y equals to modulus of sine x graph. Right. Then we are moving to next part of the topic, that is f of modulus of x graph. That means in our previous graphs, the modulus comes to entire function. Here the modulus comes to only for x, right? Then the theory of drawing f modulus of x graph is initially to draw fx as what we did in our previous theory. Then what you need to do is, in our previous case, we are entire graph will reflect from x-axis. Here the graph should be reflected by y-axis from here. Irrespective of positive or negative, it just reflects from y-axis. So initially we will draw x plus 2 graphic. Just like this, it traveling through 2. Then what happened here is that if you want to obtain the modulus y equals to modulus of x plus 2 graph means up to here the same thing. Now you have to ignore this bit. You have to ignore the negative part of the graph and reflects this positive part to the from y-axis. So this part reflect from y, just like you are keeping a mirror over here. If you keep a mirror over here, this part would be crossed and this would be reflects like this. This is the graph of that. It reflects from 2. Right? Sorry, reflects from y-axis. The intersection is 2. Right. Then let's come up with this. We have to draw y equals to 2 modulus of x minus 6 graph. Initially, we have to draw y equals to 2x minus 6 graph. Here we can understand it traveling through 3 here and 6 over here. Then what you can understand. Then the graph up to here. Nothing to worry about this negative part. Only thing is to draw up to y-axis. Draw up to y-axis and reflect this part of the graph. Erase this bit. The negative part erase totally and reflects this positive y-axis to the negative side. So therefore, the coordinate is 3. It traveling through plus 3 and this is traveling through minus 3. Here this is 6. From 6 only it reflects up to 6. We can draw the graph and then erase the negative part of the graph and reflect the positive part to the negative side. That is the answer for this question. If you want to draw y equals to modulus of x squared minus 6 modulus x minus 16 graph. Initially I will draw y equals to x squared plus 6x minus 16 graph. Here the coordinate is 8 minus 2. This coordinate is 16 and here the coordinate is 3 minus 25, right? Then if you want to draw the modulus x graph, so what happened here? Up to y-axis we can draw the same graph. Up to y-axis we can draw the same graph. Then after that what you need to do? Erase this negative part of the graph. Then reflects this one from y-axis. Assuming that here there's a mirror. If you keep a mirror here, this reflects like this. Right. So this part of the graph is like here and reflect to this side. So this is the graph of that. Right. That's a reflection from y-axis. Then let's try to draw 1 over modulus of x graph. First you have to draw 1 over x graph. Now you have to erase the negative part of the graph and you have to reflect from y-axis. Therefore you can draw the graph over here. You can if you work out, you will understand that if you draw the modulus of 1 over x graph and 1 over modulus of x graph, both graphs are same here. Keep a mind about this graph. Then if you go ahead with 1 over x graph, it's the same. Okay, it's obviously similar, right? Okay, now if you want to draw 1 over modulus of x plus t graph, initially draw 1 over x plus t graph. We already drew in our previous examples even. Then after that, what you need to do is you have to reflect from where? So you can draw the graph up to y-axis. So here most of the graph functions were disabled. That means this total part has to be erased. Take a eraser and erase this entire part of this graph. Then after that, you can reflect this bit to the negative side. So this is the positive side of the graph up to y-axis and draw, and then this part has to be deleted. So you can draw up to y-axis and here the value is 0.5. Then from there it's get reflects to over here. Sorry, not 0.5, should be 0.33. So if you intersection of the y-axis means when x equals to 0, it's 1 over 3, 0.33 up to this graph. You can draw up to here and then after that you can reflect over here. Right? If you want to draw y equals to sine modulus of x graph, initially we can draw sine x graph. It's just like this. After that, what you need to do is we have to reflect from y-axis. I just little bit expand this graph to show you more details. Therefore, what happened here is this positive graph. Up to here, the graph is same, and this is the graph has to be reflected. So if you reflect this one over here, it's like this, and this negative part goes like that. Here, the positive graph is like this, and that would be reflected over here. And this part is over here, it reflects to this side. And this part of the graph over here, it's reflected to over here. Like that, you can draw these graphs, right? Then that is the concept we have to learn about modulus graphs.